Time, we do have a warm up of just doing normal GCF before we throw that in with the star as well. So again, what we're going to do is take a minute, pause the screen, try both of these problems, just taking out one GCF. Pause it. When you have your answers, press play to see if your answers match up with mine. If they do, go ahead and fast forward to the lesson. If they do not, then I will go through it step by step so you can see again how these work. So on the first one, I had that our GCF was negative 4x to the third. So we have to put that in front, and 4x plus 5 is what should be left when you're done. On the second one, I saw that 3x to the fourth was our GCF, leaving us with x to the third plus 10. So again, go ahead and fast forward to the lesson if you got those, or stay on if you need help explaining through how I did that. So again, when you're looking for a GCF on your terms, you have to see what both terms have in common. So I always look at the coefficients first, and it's easiest to start with the smallest coefficient. So on this one, the smallest coefficient is negative 16. So I'm going to look and see what numbers go into 16 that also go into 20. So I always start with the number itself, 16. But if I divide 20 by 16, it gives me a decimal. So then, remember like how we do before, it might help if you come up with your factor tree. So 1 and 16, then there's 2 and 8. So I'm going to see if 8 works because you always want the greatest number. So I know that 8 can divide 16, but when I divide 20 by 8, I still get a decimal. So then again, going into 16, 3 doesn't work, but 4 and 4 do. So again, I already know that 4 goes into 16, so we just have to check that it goes into 20. And it does. And then another thing you have to remember here is that our first term is negative. So I know that I'm going to take out a negative 4 as my number because you never want the first term negative. Then what we're going to do is we're going to look at both of our terms to see if they both have variables. They both do have variables. And again, the smallest exponent is always how much you take out. So not only can I take out negative 4, but I also need to take out x to the third as well. So your GCF is going to go to the front, and then inside parentheses is going to be what's left once you divide. So we divide our coefficients like normal. So negative 16 divided by negative 4 is positive 4, and then you subtract your exponents. So x to the fourth, and I'm taking away x to the third, so that's going to leave me with just a single x. So next we do negative 20 divided by negative 4, which is positive 5. And I had x to the third and took out x to the third, so there should be no x's left. So after taking out our GCF, that is our final answer. Over here on the second problem, I'm going to look again. This first term is not negative, it is positive, so we don't have to worry about that this time. So again, we're just going to look at the smallest coefficient, which is 3. So I'm going to see if I can divide 3 out of my other term. When I try that in the calculator, 30 divided by 3 does give me 10. So I know that at least the first part of my GCF is 3. And again, we have x to the seventh, and the other term has x to the fourth. So we're going to take out the smallest exponent. So with the GCF, we'll have the 3, and we'll also have x to the fourth power. So again, our GCF, what we're allowed to take out, goes in front, and then we have to divide. So 3 divided by 3 is 1. You can put a 1 there or just leave it. And then x to the seventh, if I take out x to the fourth, that just leaves me with x to the third. Then positive 30 divided by 3 is 10. And if I had x to the fourth and I take out x to the fourth, then there's none left. So there's, again, just warm-ups and clarification on how to look at your GCFs. So you're going to be doing this at the beginning of your STAR problems today. All right, day 7, we are factoring again, just using more practice with GCF. So the first difference with this problem is this one is only a binomial. There's only 2 terms. So at first glance, it doesn't look like it's going to be a problem. We use the star. But if you notice here, this is x to the third. I'm missing x squared, and then there's still an x on the end. So because of exponent is missing, I can actually recreate this into a trinomial. So the first thing I'm going to do is I'm going to look for a GCF just with the two terms that were given. So between 3 and 27, I know that I can divide both of those numbers by 3. And my two terms both have at least one variable. Again, you're always going to look at the least amount. This one is just x, which is technically x with an exponent of 1. So you can just put an x, or if it helps you to remember better, you can put a 1 there, like there's a 1 here. And then we're going to divide that out. So 3 divided by 3 leaves us with 1. If you had x cubed and you're taking out x to the first, that's going to leave you with x squared. And it needs to go inside parentheses with the GCF out front. Negative 27 divided by 3 is negative 9. And you had x to the first power. We're taking out x to the first power. So we're just left with that. So again, right now we still only have a binomial, but we can rewrite this to be a trinomial. So I'm actually going to write this out to say this is 3x in the front. I have 1x squared, so you can leave the 1 there or just leave it as x squared. I have no just plain x's, so I'm going to write that we have 0x. And on the very end, there's a minus 9. So again, c is always the number by itself. B is always the number in front of x. So now we're going to label A, B, and C and do the star. So A is 1, B is 0, C is negative 9. So when I go to create the star, I'll do 1 times negative 9 on top, which is negative 9, 0 on bottom, and 1x on the two sides of the star. So we're going to make our t-chart for the number 9, so we can find all of its pairs to figure out what two numbers will multiply to negative 9 and add to 0. So I have 1 and 9. If I divide 9 by 2, it gives me a decimal. If I divide 9 by 3, it gives me 3. So there's no way to add or subtract 1 or 9 to make 0, but if I have 3 minus 3, that gives me 0. So I know that I need a positive 3 and a negative 3. So moving on to step 4, where we reduce. 1 over 3 will not reduce, so that's going to be 1 star, or 1 factor. And 1 over negative 3, again, will not reduce either. So I'm going to go back underneath the blue, underneath the original problem, and we're going to write our final answer. So the first part is we're going to bring down the GCF at the beginning, which was just 3x. The first side of the star is 1x over 3, so x plus 3. The second side of the star is 1x over negative 3, so that's going to create x minus 3. So that is our final answer and our equivalent expression to 3x cubed minus 27x. All right, after seeing the last example, you saw what looked like a binomial that we were able to change into a trinomial. On this problem, we're back to just easy 3 terms. 14x to the 9th plus 7x to the 8th minus 21x to the 7th. So again, we're going to first look, the first term is not negative, so we don't need to divide a negative out. But 14, 7, and 21, I know that they can all be divided by the number 7. So I'm going to take a 7 out of all 3 terms. And again, they all have variables on them. So always look at the smallest amount. The last term has x to the 7th, so I know that I can take out x to the 7th. So we're going to write our GCF first, and then divide that from the 3 terms. So 14 divided by 7 is 2. I had x to the 9th. I'm dividing out x to the 7th. So remember, those exponents subtract and just leave us with 2. 7 divided by 7 is 1, so you can put that there, or you can just leave it blank. X to the 8th divided by x to the 7th, that's going to leave me with just 1. Negative 21 divided by 7 is negative 3. This started with x to the 7th, so if I divide out x to the 7th, we don't have any x's left. So again, once we took out a GCF, we're back to our normal x squared x and no variable at all. So now we're going to run through and label A, B, C and fill in the star. So A is 2, B is 1, and C is -3. So on the star, we're going to put 2 times -3 at the top, which is -6. B is on bottom, and AX goes to the 2 sides. So we are going to make a T-chart for the number 6 again. So I have 1 and 6, and 2 and 3. All right, I don't need to try 3 because it's there. 1 and 6 could not add or subtract to 1, but 2 and 3 can. So I know I'm going to use 2 and 3. To multiply to -6 and add a +1, I need one of my numbers negative. Again, since the bottom is positive, I know the bigger number needs to be positive. So I'm going to make that a -2. So -2 times 3 is -6. -2 plus 3 is +1. So we're on to step 4, where we have to reduce the sides of the stars. So 2x and -2. I can divide 2 out of the top and bottom, so that will become 1x on top and -1 on bottom. Squeeze that in there. On the other side, I have 2x over 3, and there's nothing I can reduce 2 and 3 by. So that's just going to stay the same. So for our final answer, again, we start with our GCF, which was 7x to the 7th power. And then my first factor is going to be one side. So 1x over -1 makes x minus 1. The other side was 2x over 3, so that's going to be 2x plus 3. So we again factored to find another expression that's equivalent to the one we started with.